Right. So we had 93 persons in total who took the test or who responded to the test. That's screen, this screen. Right. So in terms of, you can see the class average, a mean of 27, a median of 26, and a range 8 to 41. So the lowest score being 8, the highest score being a number of persons got 41 out of 41. So you can see that. Now, in terms of the individual questions, question 1 asks you or give you some information. So the following data give revenues in millions of dollars for the last available fiscal year for a sample of 6 chartered organizations for serious diseases. And it gave you the numbers 952, 1129, and so on. And it asks you to find the mean revenue for these organizations. Now, now for a data set like that, I think somebody's trying to come in. How do you find the mean by way of review? How do you find the mean when you have on-group data like that? Anybody can answer. All right. So this is on-group data, which means that you are finding the mean for you find the mean for on-group data. So what it requires you to do is to take the sum of these 6 values and divide it by 6. And so to get, so you essentially, it's really just an addition of the 6 values and divided by 6. And so for this questions, most persons got it correct because the software, when I entered the responses, I allowed it to collect responses within plus or minus 0.5 of the correct answer. So the correct answer right to 4 decimal places being 529.6667. And so all of these would have been acceptable. That's why you see none of this is marked incorrect. So most persons would have been able to get this to within the acceptable range. See some persons, somebody rounded incorrectly here, and enter that this would never be this would never end in a 5, and none of these should really end in a 6 because the next value is a 6, and so you would have to round that up to 7. And so if this is being rounded to 3 places, it should be 0.667. Anything here should end in 7. And in the rounding rule I gave you, that we don't round to less than 3 decimal places. So these here, they weren't marked incorrectly, but really truly 3 decimal places or more. And if you're rounding in such a case, you will have to round up because it's a recurring, it goes 0.666. So if you're going to stop this at any point in time, you have to round that last 6 up to a 7. Just to be clear on that, that becomes important. Now, question 2, in the order of the questions. All right, so the next, after finding the mean, you were then asked to find the standard deviation, but in arriving at the standard deviation, you will have to go through a number of steps. You will have to first find the sum of x squared, you will have to find the variance, and then you will have to find, of course, and then finally you arrive at the standard deviation. And so to find the sum of x squared, of course, as we discussed and as you were provided in the notes and in the videos, you would have had to square all of those individual x values and take the sum of that, and that would give you the sum of x squared. And for this particular question, because they were fairly big values you were working with, you would have gotten a value of 2,705,132, and as you see, about 65% of the class got that correct. And I think this was, I know this was a multiple choice question. So you'll see this was the correct answer here, 2,705,132, and all the calculations required you to, using the same values above, you square those values and you take the sum of that. So you've had to square the 952, the 1129, 231, and so on. And so you didn't have to, you had a lot of time. So if you were doing this manually or you were doing this in a software like Excel, either way, you would have been able to calculate this correctly. So 60 of the 93 persons got that spot on. And then next you move on to finding the variance. Now, we will review the formula for the variance, but you, again, would have had access to all of that. So to find the variance would have been the sum of x squared minus the sum of x squared, and then you divide that by n minus 1, because you were told that this was a sample of 6 charitable organizations. So of course, it's sample data that you're working with and not population data. And so again, this was multiple choice. So having done that, you see 73.1% of the class got this correctly as well. In this case, it was 204, 720.267. And so 68 of the 93 persons got this correct. And so when I was saying in a previous class that the calculation questions were done fairly well, in that more than half, close to quarter of the class actually got most of these correct. The issue in this test was not really the calculation questions, because if some persons didn't spend a lot of time. When I look at the times that the submissions came in, I think some more time could have been spent on the calculations, because we only had 6 values here. They were fairly big values, but it was just 6 values. So, sum of x squared, when you square all and you add it up, minus as opposed to when you add up all and you square the sum of x, making sure, again, those numbers were in the right place. All of that would have contributed to these. As you see, some persons did not score so well on this. This one was also done well. 72% of the class got the standard deviation correctly. And so, just 1 second, I think somebody's trying to get in. Right. That just came out. Right. So again, the standard deviation would just be the square root of the value that you got at the top here. So 204, 370.267. You square root that and you get 452.073. Again, 67 out of the 93 persons, which represents 72% of the class got that also correctly. And of course, that would be affected by whether you used at the top the formula for sample data or the formula for population data. The question explicitly said that it was a sample. So that should not have been confusing. Now, in terms of the worded questions, that's where I wanted to spend some more time. Question 5 asks you, for instance, suppose a researcher was interested in summarizing the income distribution of a community that comprises 500 families. Which category of statistical techniques would you rely on to summarize the data? And if you go back to the definition of descriptive statistics, it says that descriptive statistics is concerned with summarizing, organizing, data organizing, summarizing, and then of course presenting data. And so once you're talking about summarizing, you have 500 families and you're collecting data on income for all 500 families. You will have to find some way to first put that in a frequency distribution table. You will find the mean. You will plot a bar graph. You will plot a histogram. And then you will find the standard deviation and all of those things. Those are all descriptive statistical techniques or methods. And so,
excuse me, Ms. Gail is asking to be let in.
I don't see Gail in the waiting room. I don't see her in the waiting room. I'm not sure. You can ask her to leave and try to rejoin, but I'm not seeing her in the waiting room right now. Right. So again, 77% of the class got that correct. 72 out of the 93 persons. 18 people said inferential statistics, but inferential statistics is not concerned with summarizing and organizing data. Inferential statistics is concerned with making inferences, as the name suggests, based on sample. Inferences about populations based on sample, as the next question asks you. Let's see what the next question asks you. Suppose you're interested in finding out whether there's an association between consumption of alcohol and domestic violence. Which class of statistics would you need to utilize in this determination, to make this determination? So this one would have required some thought, because now you're talking about not just summarizing and organizing, but you're talking about association. And so you will use things like correlation. That will tell you whether there's an association. Note that I was very clear. I was very deliberate in not saying relationship between the two variables. I said association. And so measures of association, like the correlation coefficient and cross tabulations and so on, those still form part of your descriptive statistics. Now, if you're looking for relationship, and so you're looking for causation, you're not looking for association, you want to see if alcohol consumption leads to or directly causes an increase in domestic violence, then you're going into inference, because inference is concerned with making those certain generalizations. You have sample data and you are going to use that to run a number of tests to determine whether there is actually a relationship between those two variables. And so if instead of association, the question had said relationship, then your answer would have been inferential statistics. But because it said association, the answer had to be descriptive, because descriptive will tell you what it is an association, but an association doesn't mean that there's a relationship. It'll tell you, you will see that you can calculate the correlation to say, okay, yeah, these two things are moving together. They're moving in the same direction or they're moving in the opposite direction, but that doesn't mean that there is. And I specifically use this example because I recall discussing it in one of the earlier classes that we had regarding the 2 o'clock curfew and the closing of bars because of the perceived association between alcohol consumption and domestic violence. But that seems to be a false association because domestic violence continues to be on the rise and the curfew is still in effect. So there's clearly no evidence that such a relationship exists, or at least the closing of bars has anything to do with the incidence of domestic violence. And so you can observe an association, but in order to find whether there's an actual relationship, then you have to go to the inferential statistical techniques, which we have not done in this course. Now, the next question says, if a survey reports that 48% of the respondents in the sample supported the position that gay couples should enjoy the right to be married, this is an example of what type of statistics? Right, so exactly what 50% of the persons said inferential statistics. Again, this one required some thoughts. I understand why the 27 people here said descriptive statistics. Yes, so I totally understand why the persons who said descriptive statistics here gave this answer, but once we're going into, you see, the thing is that mostly when you report your findings in this way to say, okay, 48% of the person said, or 65%, it's really, the purpose is usually to make a generalization. And so because of that technicality, the answer here was given as inferential statistics. What is this? Shoot. I'll deal with this after. Yeah. So, but I do get this. I do get why persons would have given that answer. Something is, the question order is showing up. Where's the first question? All right, I'll come back to the calculation questions, but somehow my question order got distorted. Oh, I know what's happening. I'm seeing I have to go back here to see the question, to see the data, because this was given as an image. Right, so here. So you were given a frequency distribution with this question. For 50 airplanes that arrived late at an airport during a week, the time by which they were late was observed. And then the table tells you the time in minutes by which an airplane was late, and the frequency, of course, tells you the number of airplanes. So this was these were your class boundaries, 0 to less than 20, and so on, all the way up to 100. You had a class size of 20. And the frequencies are given as shown in this column. And then you ask to find the mean time in minutes that these 50 airplanes were late during the week. Now, if you recall, the process for finding the mean for group data, the formula that we use for that is the sum of the midpoint times the frequency divided by the sum of the frequencies. And so that would have required you finding the midpoints for each class. Of course, the midpoint you find by summing the two boundaries and divided by 2. It's really the average of the class boundaries. So the midpoint for the first class would be 20 plus 0 divided by 2, which gives you 10. The next class, 20 plus 40, which is 60 divided by 2, which gives you 30. And then this one would have been 50, 70, 90. Now remember I said that once you find the midpoint for the first class, and you know the class width or the class size, in this case you have the class size of 20, the midpoint of your first class is 10. If you keep adding 20 going down, you're going to get all the other class midpoints. And so it's going to be 10, 30, 50, 70, 90. And so you will then multiply those values by your frequencies, individual frequencies, divided by 50, because 50 is the sum of your frequencies. And you will get the class, the mean for this distribution. And I believe that for this question, the mean was 38. Yeah, the mean was 38.6, which again, most persons got correct. 83, just about 84% of the class got this correct. There were just a few people who missed it. And 11 persons said 30.8. I think that was just an issue of not looking closely enough at the options that you were selecting, because it should have been 36.8 rather than 30.8. And then, of course, the midpoint for the third class, again, almost everybody got that correct. It would have been 50, 10, 30, 50, 50 is the midpoint of the third class. And then the class size for the distribution. I am surprised that everybody didn't get this question correct because the class size was clearly 20. Less persons got this correct than the midpoint for the third class and the mean for the distribution, which I found very odd. So the class size was 20, and a number of persons missed some easy marks here by not selecting that option. And then you were asked to find the variance and the standard deviation for that distribution. Of course, finding the variance and standard deviation for group data requires a bit more work than finding the same measures for ungrouped data. And so it's your mean, not mean, once you would have found midpoint times frequency, you needed that for to find your mean. That's one of the values that you'll also use to find your variance. But of course, to find the variance, it's the sum of m squared times f minus the sum of m times f squared. So you would have had to square all the midpoints, multiply those squared values by the frequencies, take the sum of that to get your m squared times f. You minus that from what you get when you square the value for midpoint times frequency, which is the value that you use to find mean. You square that value, You divide that by the 50, which is your sample size, and then you divide everything by 50 minus 1 because, again, you're working with sample data. There's nothing in the question to indicate that this was a population. And so you have to assume that it was sample data. And so, notwithstanding that requires a little bit more time, time was not a factor because you did have a lot of time, again, to do that. And so, if you did not use the sample formula, you would arrive somewhere here using the population formula. And so I see a number of persons selected this, but this is what you would have arrived at using the population formula. So if you didn't do the n-1, this is where you would have landed, which a number of persons did. And that's, of course, cost them, again, some marks. And so if you got this one incorrect, then it's very likely that you also got the standard deviation incorrect. 62.4% of the class got this correct. And the other persons, again, this would have been the answer if you had used the population formula, but it was not in the question to suggest population. So you could not have assumed that it was a population. Now, coming off of the calculation questions again, which of the following is an example of a discrete variable? Now, we said discrete variables, you arrive at their values from counting. Continuous variables, you arrive at their value by measuring. And so, daily commute time in minutes, you have to measure that. Anything to do with time is continuous. Anything to do with weight is continuous. Everybody stayed away from that. Age is also a continuous variable. We round it when we take age at last birthday, but it is not a discrete variable in the sense that it's not counted in discrete numbers. It's really measured in terms of how long you've been alive, basically. And so we usually round that down to age at last birthday, but in its true sense, it is not a discrete variable. The only thing here that you can count and only arrive at whole numbers is the number of babies born last year. His age, some people celebrate their half birthday, some people celebrate their quarter birthday and all that. So when you call as a child, somebody asks you, it's like, oh, I'm 10 years and 3 months or whatnot. So we were all in such a hurry to grow up. Age would not count as a discrete variable. The only variable here that would count as discrete is the number of babies born last year. The marital status, again, most persons got this one correct. Marital status of respondents in a survey represents what level of measurement. And again, the only answer there that made sense was nominal. There's no rank in marital status. Married is not higher than single or divorced or widowed or whatnot. It can be info, it can be ratio because there are no values. If you use any values, it would just be to represent a category. So 1 single, 2 married, 3 divorced, 4 widowed, 5 separated. But that's just to indicate a category. It's not, there's no value that you can attach to any marital status. And so in such a case, it has to be nominal. There's no rank, there's no order, there's no value. Right. And then the next question, a sample of 25 freshmen at a major university completed a survey that measured the degree of racial prejudice. And then you had a hint there which told you that the higher the score, the greater the prejudice. This is an example of what level of measurement. Now, it measures the degree of prejudice and it uses, based on the results, the higher the score, the greater the prejudice. it means that there's a rank, there's an order. If I score at a 3 on the scale, and somebody scores at a 5, it means that there's an order. They're higher on the scale of prejudice than I am. Or, you know, if it's in reverse, that's really what that's measuring. It's not to say that there's an interval or are there boundaries or whatnot. It just told you that the degree of racial prejudice was measured, and the higher the score, the greater the. That's what I put in there to indicate to you that you're looking at something that is ranked, something that's ordered. And so the answer that I was looking for was ordinal. And then, which of the following is not a characteristic of the mean? Now, again, more than half of the persons got the answer correctly, but it balances all the values in the data set. That is what the mean does. It sits in the center, and everything else surrounds the mean. All the other values are measured in terms of how far away they are from the mean, but it is the balancing. But this also is true, because if you take every value in your distribution and you minus it from the mean, and then you take the sum of that, you will always end up at 0. The sum of x minus x bar is always 0, because some values will be greater than the mean, some values will be less than the mean, but in sum, it all ends at 0 because the mean is that balancing figure. Another important characteristic of the mean is that, as we've said several times, the mean is not an actual value in the data set. Most of the times you calculate the mean, you will get a value that is not an actual value in your data set. It tells you a typical value, it tells you an average value, but the mean is rarely ever an actual value in your data set. The mean is a random variable. Depending on what sample you take, that will determine what value the mean will take on, but it does not take on a value. It does not necessarily take on a value that is equal to any other value in your data set. And all of these characteristics of the mean can be tested. The mean minimizes the sum of the squared variations in the score. This is another characteristic of the mean, and that is why when we do, for instance, things like regression, we use the least square method. It all surrounds the mean. The mean minimizes the variation, because the mean tells you, or is supposed to tell you, in the absence of outliers, the most typical value. So if you use the mean as a center point, then all values should be, it should lie in the center. And so in terms of how far away from the mean each value is, when you take the differences between each value and the mean, the variation that you get will be less than if you use any other value. If you use a value that's closer to the left or closer to the right, you're going to get much bigger variation in the value. But because the mean balances all the other values in the data set, it also necessarily minimizes the sum of the squared variation. Now, I cannot believe that 11 persons selected this option, which says that which of the following is not a characteristic of the mean. This option says that it is susceptible to the influence of outliers. Now, this is the primary characteristic of the mean, and that is why we often say that if your data set contains outliers, then you do not rely solely on the mean. You also take the median, because the median is an unbiased measure, and so it is not susceptible to outliers. The mean is always susceptible to outliers, and that is why this last option cannot be a characteristic of the mean. And this last option says that the mean is always more accurate than the median. That is never true. That is not a characteristic of the mean. because the median is more robust in the sense that it is not influenced by anything else around it, whereas the mean is influenced by all of the extreme values in your data set. And then, right, so when a distribution is negatively skewed, what will be the position of the mean relative to the median? Now, negatively skewed, of course, would mean that it is skewed to the left. And if the data set is skewed to the left, then it means that you have some extremely low values in there that are pulling down the value of the mean. So the mean will be less than the median. Remember, the median doesn't move from the center of the data. It's always there at the center. But if your data is negatively skewed, it means that you have extreme values on the low end, and those extreme values will pull your data set, it will pull your mean down so that it is less than the median. And so most persons got that correct. Just a few persons did not select that option. The mean is appropriate for which of the following types of data? You had 1 nominal, 2 ordinal, 3 interval, and 4 ratio. Now, we know that we cannot use the mean for nominal because nominal has the numbers have no meaning. And so it makes no sense to calculate the mean for a nominal data set. So you know that any of the options, so this one should have been easy. Only 73% person thought is correct. This one should have been easy because you know that any option that includes 1 could not have been correct. And so the only option there, and again was very deliberate in doing this, the only option there that did not include nominal was the third option. And so that was your hint that this was the correct answer. So once you cannot, it would make no sense to calculate the mean for nominal data. The numbers don't mean anything. I take all your USI and I find the mean for that. The value that I get doesn't tell me anything meaningful. So that does not work. And then, in which of the following cases would the median not be appropriate? And again, what was the percentage of, yeah, I feel like the same persons who got this one correct also got this one correct, because you know that if you're measuring at the nominal level, then none of the measures of central tendency make any make any sense calculating. So the variable is measured at nominal level. You cannot use the median or any other measure of central tendency. If you wish to report the central value of the distribution, you will use the median because the median is at the center, always at the center. The variable is measured on the ordinal level. You can use the median because the median works for ordinal data. A variable measured at the interval or ratio level has a highly skewed distribution. Now, again, and that's why I said just a little bit more thought, and some of these options would have been avoided. In fact, nobody really ought to have selected this option, because you know that once you have a highly skewed distribution, this is when you rely most on the median, because the mean will not give you the most accurate value. And so the median will be used when you have a skewed distribution because it is unbiased. It's at the center. So nobody should have selected this option. So that one again would have cost some persons some marks. So that, and then the final question is, which of the following is not a characteristic of a good measure of dispersion? And some of these things are in the notes, so I'm thinking that just looking back at the notes would have helped in some cases. Now, any measure that utilizes all the scores in a distribution, whether it's a measure of dispersion or a measure of central tendency, is a good measure. It's a robust measure. Once it utilizes all, it's robust. You want your measure to describe the average or typical variation, and that's why we use the standard deviation rather than the range, because the range doesn't tell you, it doesn't utilize all the values in the distribution, it doesn't tell you a typical variation, it just tells you in a very rudimentary manner what is the spread of the values. And then you don't want your and then of course you want your a good measure of central tendency increases in value as the data becomes more diverse or more dispersed. So as the spread of the data increases, your standard deviation, the value increases, because your data becomes, as the data becomes more dispersed, a bigger standard deviation tells you that the data is more dispersed as opposed to a distribution with a smaller standard deviation. That is a good measure because that is really what you want that's a good characteristic, I should say, because that is really what you want your measure of dispersion to tell you. What your measure of dispersion will not tell you is whether there are outliers in the data set. This is what you will get when you find your mean and you find your median and you look at the difference between the two and you say they're clearly outliers because the value of the mean is either far less or far more than the value of the mean. And so this you don't get from your measure of dispersion. So less than half of the class got this one correct, but again, just it did require a bit of thought, but I think going back to the notes would possibly have helped to some extent. So just give me one moment. Stop the recording.